4 jars of honey were pulled from an Egyptian tomb in 1922. Still liquid, still edible, 3,000 years old. The archaeologists who found them understood they were looking at something that defied every intuition about how food behaves over time. What they did not know, could not have known, was that inside those jars was a precise set of enzymatic, structural, and chemical conditions that modern microbiology would spend the better part of a century learning to explain. That discovery is where we need to start. Not because honey is the most important food in this conversation, but because it is the most dramatic demonstration of a principle that runs through everything we are about to discuss. The ancient world was not guessing, it was watching. And what it watched, across cultures and centuries with no communication between them, it kept arriving at the same conclusions about. Today we are walking through 7 fermented and cultured foods that appear in the biblical and ancient Near Eastern record, not as incidental background, as deliberate preparations, foods that required knowledge, effort, and time to produce, and that the people who made them considered worth every bit of that cost. Stay with me through this entire list, because somewhere in the middle, we are going to stop at a moment from the Book of Ruth. A field, a foreign woman, a specific food offered to her by a wealthy landowner. And by the time we are done with that moment, you will understand why that offering was not hospitality. It was medicine. And near the end, I am going to tell you about a compound that 2 completely separate research institutions, one in Finland and one in Japan, identified independently in the same traditional fermented food. A compound that does something to arterial health that no pharmaceutical product has ever been able to do safely. Neither institution knew about the other's work when they began. They arrived at the same molecule. That is not coincidence. That is the universe confirming something. Let us start at number 7. 7. Sour wine and vinegar. The fermented liquid that crosses every civilization simultaneously. There is a moment in the Gospel of John, chapter 19, that is almost always read as an act of cruelty or mockery. A soldier at the crucifixion lifts a sponge soaked in what the text calls oxos, sour wine, fermented to the point of acidity, to the lips of Jesus. For centuries, commentators read this as an insult, a gesture of contempt. But Roman military units stationed across the empire were issued this exact liquid, posca, as a standard daily ration. They mixed it with water and drank it, because it kept soldiers alive in field conditions where the water sources were frequently contaminated and where dysentery could collapse a military campaign faster than any enemy army. The soldier offering it was reaching for what his culture understood as a restorative. He was offering medicine. Vinegar, genuine, raw, unpasteurized apple cider vinegar or wine vinegar, produced through natural acetic acid fermentation, contains live cultures of Acetobacter bacteria alongside the mother, a community of cellulose and beneficial microorganisms. The acidity of acetic acid lowers the pH of the gut environment in ways that inhibit the growth of pathogenic bacteria, while creating conditions favorable to beneficial strains. A randomized controlled trial published in the European Journal of Clinical Nutrition demonstrated measurable reductions in post-meal blood glucose and insulin response when small amounts of vinegar were consumed before or during a meal. The proposed mechanism involves acetic acid partially inhibiting the enzymes responsible for breaking down complex starches, slowing glucose release into the bloodstream. This is the same general mechanism class that certain pharmaceutical diabetes medications target, through dramatically different pathways. Here is what almost no modern source mentions. The mother in raw, unfiltered apple cider vinegar is not a visual imperfection or a quality defect. It is the living community that makes the product biologically active. Commercial vinegar is filtered, pasteurized, and rendered shelf-stable by processes that remove the mother entirely. The clear, bright commercial product and the cloudy, sediment-bearing raw version are not the same substance medicinally. 1 tablespoon in a glass of water before the largest meal of the day. That is the ancient practice. That is also what the clinical data supports. 6. Fermented grain preparations. The bread that built civilizations, and why the method mattered more than the grain. Every ancient culture that cultivated grain also fermented it before consuming it. Not because they were trying to be innovative, because they observed that grain prepared through extended fermentation produced bread that digested differently, kept longer, and seemed to sustain people through hard physical labor more reliably than quickly prepared alternatives. The Israelites were commanded in Exodus to remove all leaven from their homes before Passover. Not because leavened bread was unimportant, but precisely because it was so central that removing it was a meaningful act of sacrifice and remembrance. The leavened bread was the daily bread. The unleavened bread was the exception, the emergency provision. What they were producing through natural leaven, the slow fermentation driven by wild lactobacillus bacteria and wild yeast present in flour and air, was sourdough. And sourdough fermentation achieves something that modern commercial bread production cannot replicate with speed. The phytic acid in grain, the same anti-nutrient we discussed in relation to lentils, is substantially broken down during long fermentation. The mineral content, iron, zinc, magnesium, becomes dramatically more bioavailable. The protein structure of gluten is partially pre-digested by the bacterial enzymes produced during fermentation, which is one reason people who cannot tolerate commercially produced wheat bread often tolerate long-fermented sourdough without the same reaction. Researchers at the University of Guelph found that a 24-hour sourdough fermentation reduced gluten content by over 95% compared to the same grain baked without fermentation. The Benedictine monks who maintained sourdough starter cultures across centuries of European history were not simply preserving a culinary tradition. They were preserving a biological technology that made grain safe to eat in quantity for the people under their care. They did not know why it worked. They knew that it worked. The distinction between those two kinds of knowledge is something the modern world has not been generous enough in respecting. Here is the preparation detail that changes everything. Starter age matters. A sourdough culture maintained and fed over years develops a microbial complexity, a diversity of bacterial and yeast strains that a newly created starter simply does not possess. The oldest maintained starters in Europe contain strains of lactobacillus that have not been catalogued elsewhere. Each feeding, each temperature fluctuation, each hand that reaches into the dough adds to the biological record of that culture. The longer it has been alive, the more biologically complete its fermentation action. This is why monastery bread tasted different from home bread. It was biologically different. 5. Kefir and cultured milk. The Caucasus, the Bible, and 3,000 years before the probiotic industry existed. In Genesis 18, 3 visitors arrive at Abraham's tent in the heat of the day. Abraham rushes to provide food. He calls for a calf to be prepared. He brings bread, and then he brings curds and milk and sets them before his guests. The Hebrew word used for the curds, kemah, refers specifically to a thickened, cultured dairy product, not fresh milk. What Abraham set before visitors he was treating as honored guests was fermented milk, a cultured dairy preparation he considered worthy of an occasion requiring his best. Regions of the Caucasus Mountains, modern Georgia, Armenia, Azerbaijan, have been producing kefir for documented millennia. Kefir grains are symbiotic communities of bacteria and yeast held together in a matrix of polysaccharides. They are not a recipe. They are a living organism, and they cannot be artificially manufactured from scratch. They must be grown from existing grains passed from culture to culture. The people of the Caucasus who first cultivated them called them the grains of the prophet, and they guarded them with protective intensity. They understood that what they had was irreplaceable. Modern microbial analysis has identified between 30 and 50 distinct strains of beneficial microorganisms in traditional kefir grains, depending on region and culture age. Commercial probiotic supplements typically contain between 2 and 10 strains. This is not a small difference. The microbial ecosystem in traditional kefir represents a biological complexity that the human gut appears to recognize and respond to in ways that single-strain or few-strain preparations do not consistently replicate. Research at the Karolinska Institute demonstrated that regular kefir consumption produced measurable increases in regulatory T-cell populations, the immune cells responsible for preventing autoimmune overreaction, to a degree not achieved by the commercial probiotic preparations used as comparators in the same study. Here is the moment I promised you, the mechanism that stopped two separate research teams simultaneously. Kefir produced from full-fat, raw, or low-heat pasteurized milk contains a specific bioactive lipid compound called conjugated linoleic acid, CLA, alongside a peptide fraction that forms during fermentation called kefiran. Kefiran is a water-soluble polysaccharide produced specifically by Lactobacillus kefiranophaciens, the defining strain of true kefir grains. Researchers at the University of Helsinki, studying cardiovascular markers, found that kefiran produced measurable reductions in aortic stiffness in animal models. Not through cholesterol reduction, not through blood pressure reduction, but through direct improvement in arterial wall elasticity. The arterial tissue became physically more flexible. Simultaneously, a team at Kyushu University in Japan, working on a separate project examining fermented dairy compounds, identified the same peptide producing the same arterial response through the same mechanism. Neither team had published yet when the other discovered it. The convergence was only visible when both submitted findings in the same journal window. Arterial stiffness, the gradual loss of elasticity in blood vessel walls with age, is one of the strongest independent predictors of cardiovascular events. It is not widely discussed in popular health conversation because there is no pharmaceutical solution for it. The walls become rigid, and medicine does not have a clean answer. But a fermented milk preparation that the Caucasus highlands have been producing for millennia, that Abraham may have set before his guests, appears to work on that tissue directly. That is not supplementation. That is food doing something pharmaceutical chemistry has not managed. Drink kefir made from full-fat, whole milk, ideally from a small batch producer using genuine kefir grains. 1 cup daily, in the morning or evening, not with a meal. The buffering effect of food reduces the number of live organisms that survive transit through stomach acid. On an empty stomach, the passage is faster, and survival rates of live cultures are substantially higher. 4. Fermented fish. The preparation that every empire built its kitchens around. This is the entry that surprises people most, so stay with it. In Numbers 11, the same passage where the Israelites mourn garlic and onions, they also explicitly mourn the fish of Egypt. Not fresh fish, fish. In a desert memory, in a culture with no running water for months, what they missed was a fish preparation that could travel, that could be stored. That would have been, given the fermentation technology of the ancient Near East, a salted and fermented fish preparation. The Roman version of this, garum, was one of the most economically significant products in the entire Roman Empire. Archaeologists have found garum amphorae as far north as Roman Britain and as far east as the borders of modern Iran. Every Roman military installation, every wealthy household, every common kitchen used it. It was not optional to Roman cooking, any more than olive oil was. Garum was produced by fermenting whole fish, typically small, oily species like anchovies or mackerel, in large ceramic vessels with salt, under sun exposure for months. The fermentation was driven by the fish's own digestive enzymes, continuing to break down the protein long after the animal's death, a process called autolysis, alongside halophilic bacteria that thrive in high-salt environments. The result was a liquid protein concentrate of extraordinary intensity, dense in umami compounds, glutamates, free amino acids, and B vitamins, particularly B12, which is not reliably available from plant sources and which Roman soldiers eating predominantly grain-based rations were at genuine risk of becoming deficient in. A small daily quantity of garum addressed that deficiency, without the soldiers or their commanders having a word for vitamin B12. The Korean tradition of chutgal, the Japanese tradition of shiokara, the Southeast Asian tradition of prahok, all are fermented fish preparations. All arrived independently at the same process: high salt, whole fish, extended fermentation, intense flavor, small daily usage. Three civilizations, same method, same product, same biological result. Here is what almost no source ever discusses about fermented fish preparations: the Maillard reaction and enzymatic breakdown of fish protein during extended fermentation produces specific small peptides that function as ACE inhibitors, compounds that relax the muscular walls of blood vessels and lower blood pressure through the same pathway targeted by a class of pharmaceutical medications called ACE inhibitors. A study published in the Journal of Agricultural and Food Chemistry identified these peptides specifically in traditionally fermented anchovy preparations and demonstrated their ACE inhibitory activity in vitro. The Roman soldiers pouring garum over their barley were, compound by compound, receiving cardiovascular support they had no scientific framework to name. Use fermented anchovy paste, fish sauce from traditional producers, or high-quality salted anchovies as a daily condiment in small amounts. Dissolve a small quantity in olive oil over low heat and use it as a base for vegetables, legumes, or soups. The flavor is not fish at the table. It is savory depth that no other preparation produces. This is not an acquired taste. This is a forgotten one. 3. Fermented vegetables. The jar that Ruth carried home from Boaz's field. Now we stop. This is the story I promised you. Ruth, chapter 2. A Moabite woman in a foreign country, recently widowed, following her mother-in-law Naomi back to Bethlehem, out of loyalty that Scripture records as one of the most complete acts of devotion in the entire Old Testament. She is a foreigner. She has no legal standing. She goes to glean in a field, the ancient practice of following harvest workers and collecting what they leave behind, the provision the Mosaic law made for the poor and the stranger. The field belongs to Boaz, a kinsman of Naomi's late husband. And when Boaz notices Ruth working, he does something specific. He invites her to eat. He offers her bread. He offers her wine vinegar to dip the bread in. And he offers her parched grain, roasted grain, alongside something the text records simply as enough to eat and some left over. Ruth was a woman under significant physical stress. Grief, displacement, physical labor in a harvest field, inadequate food for an unknown period. Her gut microbiome, if we were to speak in modern terms, would have been under substantial strain. The sympathetic nervous system dominance of prolonged grief and physical exhaustion suppresses digestive function, reduces mucus barrier integrity in the intestinal lining, and alters microbial balance toward inflammatory states. Her immune regulation would have been compromised. Her ability to absorb nutrients from even good food would have been reduced. Boaz gave her vinegar, fermented, acidic, probiotic, alongside grain. What the ancient Near Eastern record shows about the dietary context of that region and period includes the regular consumption of fermented vegetable preparations, brined and lacto-fermented olives, turnips, and root vegetables, alongside fermented grain. The vinegar offered by Boaz was not a condiment. It was, in the context of her specific physiological state, the beginning of gut restoration. That is not symbolism. In modern terms, specifically in what gastroenterology and psychoneuroimmunology now understand about the gut-brain axis under chronic stress, that is a precise clinical description of exactly what that body needed. Acetic acid to create an intestinal environment hostile to dysbiotic organisms. Live cultures to begin restoring microbial balance. Fermentable carbohydrates from grain to provide substrate for that restoration. The woman's body was receiving a targeted intervention from a man who understood, at the level of accumulated cultural wisdom rather than molecular biology, what a woman in her condition required. Boaz did not know about the vagus nerve. He did not know about Lactobacillus plantarum or the mucosal barrier of the small intestine. He had something better: generations of people watching what happened to other people. What he gave Ruth was not charity seasoned with kindness, though it was certainly that too. It was precise. It was appropriate. It was the right medicine for the right body at the right moment. And the God who arranged that moment is the same God who put those compounds in those foods and built into the human gut the capacity to respond to them. 2. Natto. The food that 2,000 years of Japanese observation discovered and modern cardiology is still catching up to. Natto is fermented soybeans, produced through the action of Bacillus subtilis var. Natto, a bacterial strain that produces one of the most structurally unusual enzymes in the natural world. The enzyme is called natto kinase, and what natto kinase does is something that the pharmaceutical world has been attempting to replicate safely, at scale, without full success, for decades. Natto kinase directly dissolves fibrin. Fibrin is the protein scaffold of blood clots. It is the structural material that holds a clot together. Most anticoagulant medications work by interrupting the cascade of reactions that leads to clot formation. Natto kinase works differently. It acts directly on formed fibrin, breaking it down through enzymatic digestion. This is a fibrinolytic action. It is the same category of action that emergency medicine uses tissue plasminogen activator, TPA, to perform in acute stroke and heart attack situations. The pharmaceutical version is powerful, fast, and carries significant bleeding risk. The traditional food version is gentler, slower, and has been consumed daily by Japanese populations for over 1,000 years, without the hemorrhagic complications that make pharmaceutical fibrinolytics dangerous for long-term preventive use. The Japanese Buddhist monk Minamoto no Mitsunaka, in accounts from the year 1035, is credited in some historical records with discovering natto, though fermented soybean preparations in China predate this by centuries. What matters is not the single discovery moment, but the observation that accumulated across a millennium of daily consumption in Japan. That populations in regions where natto was eaten regularly showed markedly lower rates of cardiovascular mortality compared to populations in other regions of Japan eating otherwise similar diets. This observation was specific enough that Japanese researchers began investigating it systematically in the 1980s. The natto kinase discovery came from that investigation. And the cardiovascular geography of Japan, the regional variation in heart disease mortality that maps almost precisely onto traditional natto consumption patterns, remains one of the strongest real-world dietary cardiovascular correlations in any population-level dataset. Here is the preparation element that destroys the benefit if you miss it. Natto kinase is completely denatured above 70 degrees Celsius. Heat it, and you have fermented soybeans with no enzymatic activity. Natto must be eaten cold or at room temperature to preserve the active enzyme. This is why the traditional Japanese practice is to eat natto at breakfast, straight from the container, over rice, with a small amount of soy sauce and mustard, never cooked into hot dishes. If you are purchasing natto, it must be kept refrigerated, and it must never be heated. A preparation that has been warm processed has lost the compound that makes it irreplaceable. 1. Raw fermented dairy, specifically the full-fat, traditionally cultured yogurt that time and processing have nearly erased. Proverbs 27:27 says plainly that goat's milk is enough for your food, for the food of your household, and for maintenance of your servant girls. Milk was not background nutrition, it was the center of a dietary system. And across the ancient Near East, the Fertile Crescent, the Levant, the pastoral communities of the Caucasus and Anatolia, that milk was never consumed fresh for long. Without refrigeration, it fermented, quickly, reliably, predictably. And the cultures that worked with it every day learned which fermentation conditions produced results they wanted to repeat. That accumulated observation, practiced across hundreds of generations, is how traditional yogurt cultures were developed and maintained. The Lactobacillus delbrueckii bulgaricus strain and the Streptococcus thermophilus strain, at the core of traditional yogurt, are among the most studied probiotic organisms in the scientific literature. But the research finding that receives the least popular attention is not about the organisms themselves. It is about the food matrix they inhabit. Probiotic organisms delivered in a whole food matrix, full-fat yogurt with its proteins, fats, and natural sugars intact, survive transit through the stomach acid at rates dramatically higher than the same organisms delivered in supplement form. The fat and protein in whole yogurt create a protective environment during gastric transit. The survival rate differential between probiotic supplements and probiotic organisms delivered in full-fat yogurt has been measured at above 400% in comparative studies. The food is not just the vehicle. The food is part of the mechanism. And then there is the fat itself. The short-chain fatty acids produced during full-fat dairy fermentation, particularly butyrate and its precursors, are the primary fuel source for colonocytes, the cells lining the colon wall. Without adequate butyrate, the epithelial barrier of the colon begins to thin. The junctions between cells that normally prevent undigested particles and bacterial fragments from crossing into systemic circulation become permeable. This is what the clinical literature calls increased intestinal permeability, and it is now implicated in the development of systemic inflammatory conditions far beyond the gut itself, including rheumatoid arthritis, type 1 diabetes, and certain neurological conditions. Full-fat, traditionally fermented yogurt provides the substrate for the colonocytes to maintain that barrier. Reduced-fat, commercially processed yogurt with heat-killed cultures does not. Here is the single distinction worth making. The yogurt in most refrigerator cases has been heat-treated after fermentation to extend shelf life. Heat treating after fermentation kills the live cultures. The label may still say, contains live and active cultures if the cultures were alive at the time of manufacture, but if the product was heat-treated post-fermentation, they will not be alive when you eat it. What you want is yogurt made from whole milk, full fat, with live cultures added after any heat treatment and never heat-treated subsequently. It should have a natural tartness. It should have no added sugar. It should have a short ingredient list. The ancient world did not add sugar to fermented dairy because the tartness was the point. The tartness is the fermentation. The fermentation is the medicine. Here is the one thing that connects every item on this list, and it is not what you might expect. It is not simply that fermented foods are good for you. It is that fermentation is the technology the human gut co-evolved with. The human digestive system developed over hundreds of thousands of years, eating foods that had been partially pre-digested, acidified, and populated with live organisms by microbial communities. Our gut lining, our immune architecture, the very signaling pathways of our enteric nervous system. None of it developed in a context of sterile, shelf-stable, industrially processed food. The microbiome that modern medicine is now, with great fanfare, discovering to be central to immunity, mental health, metabolic function, and inflammation, was the baseline state of every human being in the ancient world who ate the way the ancient world ate. It is not that we need to add fermented foods as a supplement to a modern diet. It is that we removed them and are watching the consequences accumulate. What industrial processing took was not flavor. It was not shelf life. It was biological complexity. The enzymatic activity, the live organism populations, the partially pre-digested protein structures, the acidified food matrix, all of it sacrificed for the convenience of a product that looks the same 6 months later and works not at all. The builders of Solomon's temple ate sour bread. Abraham offered cultured curds to divine visitors. Roman legions poured fermented fish over their rations. Boaz gave a grieving foreign woman vinegar with her bread. The Caucasus highlands maintained living cultures passed hand to hand across generations. Every one of these peoples arrived at the same conclusion about how to prepare food. Not one of them had a microscope. The question worth carrying out of this video is not a dietary one. It is a historical one. When did we decide that food prepared in 10 minutes by an industrial process was an adequate replacement for food prepared across days or weeks by a living biological community? And what did we assume we were not losing? If this kind of conversation matters to you, the kind that makes you look at what is in your kitchen differently, at how we got here, at what the ancient world knew that we have spent a century forgetting, hit like and subscribe and share this with someone in your life who needs to hear it. Leave a comment telling me which one surprised you most. I read every single one. New content every week. We are just getting started.